Thank you. Okay. So again, we're given this function f of x here. We want to find the vertical asymptotes. The vertical asymptote is at some position of x is equal to something, right? And the function is not defined somewhere there. We want to find the limit where fx goes when x comes closer to that specific numbers. In this case, there's one vertical asymptote at x equal to, is it?
5/3.
Yes, 5/3. That is where the denominator is not defined. So in order to find the vertical asymptote, we need to find the limit of this function when x comes closer to 5/3 from the right-hand side and the left-hand side. And the horizontal asymptotes, as I mentioned yesterday, there are at most two horizontal asymptotes. And in order to find that, we find the limit of this function goes to infinity or negative infinity. Okay. Yesterday, we was finding the limit of this function when x goes to infinity to find the first horizontal asymptote. And here, the tricky part is this radical sign here. Okay. And the highest degree, when we divide this portion, both numerator and denominator, by the highest degree of the denominator. This is the trick. And this is some observation. The highest degree of the numerator is the highest degree of the terms under the radical sign, but then it is square root here, right? Or in other words, square root of x squared is the highest degree of this guy, or it is of the order 1. So again, we should be careful about this. Square root of x squared will be absolute value of x. If x is positive, then we can get rid of the absolute sign. Otherwise, absolute value of x should be negative x. Then we do this by dividing both numerator and denominator by x to the 1 here. Then we do some algebra, right? We try to manipulate this term and write it as square root of x squared. Then remember the formula, square root of a over b is square root of a over square root of b. Actually, b is not 0. Okay. We apply to this situation. Then we can write this as the limit of this guy. And the denominator, we simplify it, we got this one. Okay. Now let us continue. So here, this is a quotient, right? Then which limit laws should we use here? Yes, the quotient rules. So the quotient rule here, it will be the limit of the numerator, which is 2 plus 1 over x squared, right? Divided by, again, we should write it this way, the limit when x approaches infinity of the denominator. So the limit laws we use here is the quotient rule. For limit, okay? And then the next step, what should we do? Yes. Thank you, Christian. Then we use the root laws for the numerator, right? And the denominator, let us use do something with the denominator at the same times. Yes, the subtraction laws. Very good. Thank you so much. So anyways, we write it as square root of the limit when x approaches infinity of 2 plus 1 over x squared divided by, again, this is here, the limit of this constant when x approaches infinity minus the limit when x approaches infinity of 5 over x here. Okay. So indicate the limit laws here. Then again, we use the sum law, right? Then it will be limit of 2 when x approaches infinity plus the limit of 1 over x squared as x approaches infinity. And the denominator, what is the limit of 3 when x approaches infinity? 3. Yes, thank you. And here, this guy? 0. Very good. Wow. Okay, it's easy, right? Now it will be the square root of? 2. Yes. Right, it will be? So this is the horizontal asymptotes as x approaches infinity. Well done. Is it clear?
Would that be the positive and negative version, since we're going from infinity and negative infinity?
Yes. And this is the first step. We found one horizontal asymptote. Okay. The second one. So let us find another horizontal asymptote. By computing the limit as x approaches negative infinity of square root of what is it, 2x squared plus 1? Yeah.
Why would you make infinity?
1 second. 3x minus 5. Okay, now let us try to sketch the graph here. Any function in 2D, Cartesian coordinate, right? We want to understand, guess how it behaves. And when we take x approaches infinity, it means that we are taking in this direction. We wonder where it behaved. And here, we found it here, square root of 2 over 3, right? Square root of 2 over 3 is smaller than 1. Suppose it is right here. And this line is the square root of 2 over 3 lines here. And we don't know how this function behaves, but we know that when x becomes very large, the line should be somehow like this or like this. This is the horizontal asymptote. When x approaches infinity, and if x becomes very small in the negative direction, where does it go, right? F of x goes. Whether it is becoming closer and closer to this, or it becomes closer and closer to this one, or it could be somewhere near a different lines, near this line or this line, right? We don't know. That is why we need to find the limit. Okay. One more thing. There is one vertical asymptote here at 5 over 3. Suppose 5 over 3 is this one, is this line. Okay. This is the vertical asymptote. And we know for sure that any point here in this line will not belong to the graph. But we don't know what it looks like. Then we need to compute the limit as x approaches 5 over 3 on the right-hand side or on the left-hand side. But we'll do it later. Okay. For now, let us continue. That is why in this step we need to compute the limit as x approaches negative infinity here. Okay. And the same trick here, we will divide both numerator and denominator by the same guys, right? Which is yes, and square root of 2x squared plus 1 here, it is also divided by x. Very good. This is what we're doing. Okay. But now it's very tricky because here x is go to negative infinity. Okay. And we know that as x is going to infinity, then last time we have written that, okay, absolute value of x is negative x if for x is negative, right? We know this. What does it mean? If we write it here, absolute value of x is square root of x squared. Is it okay with you? Another way to write absolute value of x. They are the same thing.
So now you can replace it with a different-
Yes, but now we are given x here, right? So what should we do? We have negative x. Here we have x here. Can we just write it this way? Is that okay? Are we good? Then, okay, if x is negative, then we replace x by negative square root of x squared. Are you comfortable with that? Then just replace it. Okay. Then this guy will be the limit. When x approaches negative infinity of square root of 2x squared plus 1 divided by negative square root of x squared. Oh, nice. And the denominator, let us simplify it, right? It will be?
3 minus 5 over x.
Yes, very good. Now the same trick here. The negative sign here, we can always write it as -1 times square root of x squared, right? And again, we deal with this product. Okay, what is it?
Square
Mhm.
-2 over -1 over x squared.
Be careful. We just take the x squared into the square root sign, right? And the negative sign, let us leave it outside. Is that okay? If you want, you can write it as -1 times this. Is that okay? Then it should be 1 divided by -1, right? Or -1 here. As x approaches negative infinity, of the denominator 3 minus 5 over x here. Is it okay? Do you see why we have the -1 is right here? Let us write it this way. It is 1 divided by -1. Okay? And they're the same thing. People in the back, Do you agree with this? People on Zoom, do you all agree with this? Okay. Then that is the most tricky part. Let us continue. Here, the same laws, right? We see the quotient laws and then radical laws, etc. And we do the same things. We know that it finally becomes negative of the square root of the limit. Inside here, we do some similar computation. It would be 2. And what here? Yes. Divided by the denominator. The limit is x approaches negative infinity of 3 minus 5 over x here. We skip some steps and it still makes sense for you, right? You can do the similar things in the exams. If you have done something previously and you do repeat the process, the same process, it makes sense. But at the first time, if you don't do this, people may argue that, okay, you copy from someone else and I don't know, but just makes sense. Now, the same things, the addition laws and the subtraction laws, right? Anyway, it would be negative of the limit of 2 as x approaches negative infinity plus the limit as x approaches negative infinity of 1 over x squared here, then divided by the denominator limit of 3 as x approaches negative infinity minus the limit x approaches negative infinity of 5 over x here, and infinite properties of this limit. This guy will give us 2, right? And finally, it will be, what is it inside?
2 plus 0.
And the denominator?
3 minus 0.
Yes. Finally, it will be
Negative root 2 over 3.
very good. It means when x goes to negative infinity, f of x will come closer and closer to this value, the negative value of the previous one. Okay? Is there any question? We're good, right? Then let us continue. Let us find the vertical asymptotes. By computing first the limit of this function 2x squared plus 1 of 3x minus 5 as x approaches 5 over 3 from which side do you want?
Right.
Sorry,
The right.
the right, then okay, plus. What should we do with this guy? If you plug it in, the denominator will become 0, and it's not a good way, right?
You can multiply the entire fraction by square root 2x squared plus 1 to get rid of the square root on top.
So if we do so, what do we have in the next step? If we multiply with the same square root, right? Okay, let us write some suggestions. Say it again, Sarah. What did you suggest?
I said that we multiply
Negative of the square root. Let's see. You mean this term? How about others? What do you think?
Would it be the square root of 2x squared minus 1?
2x squared minus 1. So first, let us discuss this guy. This guy, when you multiply it and the numerator becomes, we will get rid of the radical sign for sure. Yes, very good. However, the denominator still has this term, right? Then again, we cannot substitute the value directly here. It doesn't solve the issue. If we do the way Christian suggests, let us try. If we replace this guy by the negative value here, and suppose the same things, right?
What about 3x plus 5?
Let's try. Very good. How about, as Madison suggests, we multiply with the conjugate of this guy, 3x plus 5. If we multiply the denominator by this term, we should also multiply this with the numerator, right? Everyone, take a piece of paper, try to do it yourself here from here. We will double check it together in 1 minute. People on Zoom do the same thing and see if you can find it. It's a trap, right? Do you see it? No, it doesn't solve the issue here, right? Because it still becomes a very big number divided by another big number. So it doesn't work this way. But we can always do some arguments here. So it doesn't work, but it's a good idea to deal with these kind of problems. But it doesn't work this case. But remember that this is how we deal with these guys. Okay, first, look at the numerator. So if x is larger than 5/3, 2x squared, how does it compare to observation? X squared is always larger or equal to, yes, Then 2x squared will always larger or equal to? Yes. And then, therefore, 2x squared here plus 1 is always larger or equal to? Yeah, 0 is still okay. But this is a better estimation, right?
So could you just square the top and bottom?
Wait a minute, okay? Then if here we take a square root of this positive number, we see that 2x squared plus 1 and then square root is always positive, right? The numerator is always positive. Okay? Now, look at this function. Three x minus 5. If x takes value negative infinity to 5/3 and to positive infinity, we know that this function is equal to 0 at this guy, right? If x is larger than 5/3, is it positive or negative? Positive. Very good. If x is negative smaller than 5/3, is it positive or negative? Negative. Very good. So, and we're considering the limit of this guy, right? We're taking the limit of x when x approaches 5/3 from the right hand side. And we know that the denominator is also positive, right? So the numerator is a positive number divided by another positive number. But the difference of this guy is x approaches 5/3, this guy becomes very closer and close to 0, right? It means it will be a constant divided by a very small numbers, or the limit of that will be, yes, positive infinity or infinity. Is it clear why it is approaching infinity? It's by some argument. We should make sure that we understand this part. Is it okay? Or consider this. One over x. When x approaches 0, from the right hand side, what is it? Infinity, right? The same things. The numerator, if it approaches 5/3, then the numerator will be 2 times 5/3 square plus 1, and then take the square root. It will be simply a number, okay, close to that value. Anyway, it is positive, yes.
So if it's 5/3 into like the negative sign, that be negative infinity?
Very good. But then the next part. Do you understand why it is when it approaches 5/3 from the right hand side, this guy goes to positive infinity?
Because the denominator gets smaller and smaller.
Yes, but it's still positive, right? A number divided by a very small numbers, but a positive one. Then the limit will goes to infinity. And the same things, we see that the limit as x approaches 5/3. From the left-hand side, then the denominator here is a negative number, right? Because x is always smaller than negative 5/3. This guy is always negative. Right? And this guy is positive, but it approaches a constant. Then the limit of this will be, what is it?
Very high negative.
Yes, very negative one. So is it clear? So we found the limit of this guy as x approaches 5/3 from the right-hand side. From the left-hand side, we can somehow sketch a graph of this one, as not perfectly, but we know it how it's behaved. So we know that when x approaches infinity, then it will come closer and closer to the line. If I remember correctly, is this square? Thank you. Square root of 2/3, and then below that it will be negative square root over 3, and at 5/3, the graph should be somewhere here. At 5/3, it will be positive here, right? On the left-hand side, oh, this is it's not a good way to write it. It should be 5. Should write it here on the left. Okay, if it approaches 5/3 from the left, then it is a negative infinity. It should be somewhere here, right? And we know that is x goes to infinity. It should be somewhere here. Okay, and closer to this line. Then we guess it should be somehow like this. Okay, let's try to plot this function with decimals here and see how it behaves. Okay, the function f of x here is equal to square root of 2x squared plus 1 divided by 3x minus 5. See it? And here is x is equal to y is equal to square root of 2/3. You see this horizontal asymptote? And the second horizontal asymptote is very interesting here, right? Our graphs here on the right range, it is above this 5 square root of 2/3, but here in the left range, it converges to negative 2/3, but above this line. Okay, and at x is equal to 5/3, this is the vertical asymptote, the purple one. The graph does not cut this line at any point. Okay, so understanding the limit of this, we will know how the function behaves a little bit of this. Are we good now? Very good. Now let us try to find some other example here. Okay, here is another example of limit as x approaches infinity and negative infinity. X cubed as x approaches infinity, f of x will goes to infinity, right? And as x goes to negative infinity, f of x will goes to negative infinity. If we know the limit, then we will estimate how it behaves at the end, right? And there's no vertical asymptotes in this case because this function is a polynomial. It is continuous. Okay. Then the graph of this is this guy. Very nice. Okay. And the precise definition of this, we don't have to study that. I just posted here for you to study and understand. But now let us do another example here. This one is interesting. The limit when x approaches infinity of square root of x squared plus 1 here. I think we've done that before. Okay. Can we estimate the limit of this guy? Can we use the subtraction laws right away? If we do, right? If we do, then the limit of this is x approaches infinity of this one. Limit of x here. It will be infinity subtract infinity, and we don't know what it is. Okay, then it doesn't work this way. We cannot find this way. Okay, so what should we do? And what is the highest power of this? 1. But if we divide by x to the 1, what do we have? So if we do divide this guy by x, then we must multiply by x, right? We must multiply by x again. Then we still don't know. But the trick Madison suggested in the previous example may help. Yeah, if we multiply with the conjugate of this guy, then we may get rid of the square root sign here, right? So remember, keep it in mind, if you see the square root here or anywhere, you may try to use this formula to get rid of this. This is a very useful formula. It will help you to get around the radical sign. Okay? Yes.
Can we just try to square the whole problem? Wouldn't we just get x squared plus 1 minus x squared?
Yeah, that is what we are trying to do. But in order to get that, we must multiply with something, which is the conjugate of this guy. It is x squared plus 1, subtract x here, right? We somehow multiply with this term. It changed the problem. Therefore, we must divide it by the same guys. Okay, when we multiply with something and divide it by itself, it will be okay. Nothing's changed, right? Oh, does it help here? Oh, plus, yeah, my bad. Thank you, Sarah. Then, what should we do next? Yeah, distribute this. It will be, what is it here? The first guy square. Yes. Subtract. Yes, x squared here. The denominator. Good job. Right. Then can we simplify the numerator here? Yes, just 1. Oops, why did I do that? It is 1 divided by the denominator. Okay, a number divided by something, and that things get bigger and bigger as x goes to infinity. It means that, okay, 1 will divide it by very big numbers, and finally it will be?
0.
Yeah, it is 0. Okay. 1 is a number, right? You have $1, you distribute this for everyone else. This, yeah, similar things, right? Okay. Is it clear? Let us do one more example. This one is very quick. Limit is x approaches 2 plus of arctan of 1 over x plus minus 2 here. Ooh, interesting. What should we do? We cry, right? Okay, again, let us draw the unit circle. Do you remember where the tangent axis is? Yeah, on the right here, right? This is the tangent axis. So for any given angle alpha on this unit circle, we connect the line from the origin to that point on the circle. Wherever it cut here is the value of tangent. Okay? If x approaches 2 from the right-hand side, what is the denominator? It will come to 0, right? But is it positive or negative? Positive. Why? Yes, from the right. Therefore, this guy will come to 1 over something very small, but positive. It means that this guy will come to, yes, positive infinity, right? And the tangent, the arctan, the tangent function, if you are given an angle, you will find a value. The arctan, if you're given a value, we need to find the angle, right? If suppose we're given an angle which is somewhere here on top of here, very positive, right? Then what is the angle that make that value? Again, please. It closer to this guy, right? No, this guy is pivot 2, right? 90, yeah, 90 degree, or arctan of this will comes to pivot 2. Do you see why it is? Question? Okay, then we know that this guy, then therefore the limit of this guy when x approaches 2 from the right hand side will somehow similar to the limit of arctan of, let's say, infinity, right? If we use a different notation, or it would be pi over 2. This is, it's not a good way to write it, but this is how you even think about it. And in short, it would be simply pi over 2. Thank you. Have a good one.